All right, so just to recap, on Tuesday, we went through the three main types of factoring, that being greatest common factor, MAF, and difference of two squares. Greatest common factor, MAF, and difference of two squares. So, just to recap here. Greatest common factor is your first method of factoring. So before you do anything else, you use MAF. I mean, not MAF, greatest common factor. Take out whatever the greatest common factor is, if there is one. Then you have MAF if you have three terms. You can only use MAF with three terms. And the last method we went over on Tuesday is difference of two squares. You use difference of two squares if you have two terms that are separated by a minus sign, and both of the terms are perfect squares. Both of the terms are perfect squares. So we did 9 examples on Tuesday, 3 of each type. These notes are already on Google Classroom, with the YouTube link that goes with them. So feel free to use them as you need to. So now we're going to use these methods to solve an equation by factoring. We're going to use what we did on Tuesday, solve an equation by factoring. So, solving the equation by factoring requires the equation to be equal to 0, requires us to factor it, and then requires us to solve out the problem. Now, if the equation is already factored and the equation is equal to 0, then set each factor equal to 0 and solve the equation. So if it's already been factored for you and it's already equal to 0, then all you have to do is break the problem apart, start solving. So if you've got x minus 5 and 2x plus 3 equal to 0, well, that's already factored. It's already factored. So what you would do is take each part and set it equal to 0. Take each part, set it equal to 0, and then you would solve it. So x minus 5 equals 0. Add 5 to both sides. X equals 5. 2x plus 3 equals 0. Subtract 3. And then divide by 2. So there's your two answers. So if it's already factored, then that work is already done for you. Split it apart, solve the two equations, keep it moving from there. Any questions with example 1? Any questions with example 1? So if it's already factored, then it's already factored, split it apart, keep it moving. If it's not already factored, then we have some work to do. So to solve a quadratic equation by factoring. Step 1, rewrite the equation so that it equals 0. So for the example that I've already done for you, 3x squared plus 7x equals -2. We need the equation to equal 0, so we need to add 2 to both sides. So we add 2 to both sides. That gives you 3x squared plus 7x plus 2 equals 0. Now, just because the 2 is under the 7x does not mean you add those together. Those are not like terms. Those are not like terms, so you cannot put those together. So you write them and keep it moving. Step 2 is the factor. So, first step in all factoring is to take out the greatest common factor. With 3, 7, and 2, there's no number that divides out. There's 3 terms, so this is an MAF problem. So, A equals 3, B equals 7, C equals 2. So remember the M is to take the A times the C value. 3 times 2 is 6. The A is equal to the B value. You need 2 numbers that multiply to 6 and add to 7. That's 1 and 6. Since your A value is 3, you divide by 3. So 1 divided by 3 would stay 1/3. 6 divided by 3 is 2. You get 3x plus 1 and x plus 2. That's your factor. So then walking you through the problem that's already solved. Step 3. Set each factor equal to 0. 3x plus 1 equals 0, x plus 2 equals 0. And then step 4, solve each individual equation. So for 3x plus 1 equals 0, we would subtract it 1, and then divide it by 3. So x equals -1/3. For x plus 2 equals 0, we would subtract it 2. X equals -2. So that's the 4-step process that we're going to take if we are factoring it. If we are factoring it, that's the approach. Any questions before we continue? All right, so let's rock and roll. We're going to do 4 examples. Some of these problems will involve greatest common factor. Some will involve difference of 2 squares. Some will involve MAF. Some may involve more than one factoring method. The steps do not change. So example 2. 6n squared minus 15n equals 0. Step 1, rewrite the equation so that it equals 0. It's already equal to 0. So we don't have to do step 1 then, because it's already equal to 0. Step 2, factor the expression. we have to factor 6n squared minus 15n. So we always start with greatest common factor. We'll look at what can we take out of 6 and 15. So what can we take out of 6 and 15? You gotta divide something out. Take a moment to think about it. Hopefully you're calibrating that it's 3. Take out 3. Both terms have a variable, so you're going to take out an m. So 3n, parentheses, 6 divided by 3 is 2. N squared divided by n is n. Minus 15 divided by 3 is 5. N divided by n drops out. Now, you might be looking at 2n minus 5 and asking yourself, there's two terms, there's a minus sign, can I use difference of two squares? The answer to that is no. 2 is not a perfect square, so that already eliminates difference of two squares. So this is factored the way it is. Any questions before we continue? All right, then let's keep going. Step 3. Set each factor equal to 0. So we break the problem apart. That's 3n equals 0, and 2n minus 5 equals 0. So now we solve each individual equation. So for the first equation, divide both parts by 3 and equals 0. Second equation, add 5 to both sides. Divide by 2. So n equals 5 over 2. There's your two answers and the problem's over. There's your two answers and the problem's over. Any questions on example 2? If you have questions, make sure to ask. A week from today, you take your the first part of your final. Once the final exam starts, there's no other help I can give you. You're on your own. Not hearing any, not seeing any in the chat, I don't think. Not seeing any in the chat, so let's keep going. Example 3. Same rules apply. 4n squared equals 25. Four n squared equals 25. So this time, this is not equal to 0. So it's not equal to 0. So we need to take the opposite to move it. So you take the opposite to move it. So the opposite of 25 is negative 25. So you're going to subtract 25 on both sides. You can subtract 25 on both sides. 4n squared minus 25 equals 0. Four n squared minus 25 equals 0. So we've done the rewrite. Now we need the factor. First step is always, can I take out the greatest common factor? 4n squared minus 25. Can't take anything out of that. The greatest common factor is not going to work. We have two terms. So maybe difference of two squares can work. We have two terms. We've got a minus sign. And we've got 4n squared and 25 all over the perfect squares. That's the difference of two squares from. So again, if you struggle with trying to figure out what method goes with which, if you're struggling with that, you've got a whole page that goes through the three methods and what you need for each method. You've got a whole page that you can use as a guide. It's like an instruction manual. If you're going to refer back to it, do it. But it's on you to refer back to it. So let's keep things moving here. 4n squared minus 25. Difference of two squares. So we take the square root of 4n squared. The square root of 4 is 2. The square root of n squared is n. The square root of 25 gives you positive 5 and negative 5. So your factored format, 2n plus 5, 2n minus 5. Pause for a second. Any questions before we navigate forward? Let's keep it moving. 2n plus 5, 2n minus 5. Now we split the problem apart. Solve each of the two equations. So subtract 5 on both sides. Divide by 2. So that equals negative 5 over 2. Go to the other equation. Add 5 on both sides. Divide by 2. Positive 5 over 2. There's your two answers. your two answers. So for example 3, we use the difference of two squares to help us with that problem. Any questions, examples 2 or 3? All right, let's say you're hearing any. Let's move to example 4. So example 4, 8q to the third, 8q squared plus 10q equals 3. So example 4, the same concept, same rules apply. First step, we need the equation equal to 0. You have a plus 3, we have to get rid of it. So to get rid of the plus 3, we're going to have to subtract it. We're going to have to subtract it. So 8q squared plus 10q minus 3 equals 0. Now we can factor. So the greatest common factor should always be the first thing you try, but there's nothing that divides out of all 3 terms evenly. The GCF is not going to work. There's 3 terms, so let's try MDF. So A equals 8, B equals 10, C equals -3. That means your M value is 8 times -3, -24. Your B value becomes the add value. So we need 2 numbers that multiply to -24 and add to a positive 10. Again, if you need to list them out for yourself, feel free to do so. There's no shame in doing that. Because ultimately, you have to pick the right combination in order for this to work. You need the right combination in order for this to work. So 2 numbers that multiply to -24 and add to a positive 10 would be -2 and positive 12. -2 and positive 12. And since your A value is 8, you divide by 8. So -1/4 and 3/2. Any questions before we continue? If you have questions, make sure you speak them, otherwise, just so you know what you're doing. Time to put them in parentheses. So q squared is q times q minus 1/4 and plus 3/2. Remember, we don't want fractions in the factor. So take the 4, move it in front. Take the 2, move it in front. 4q minus 1. 2 cubed plus 3 equals 0. So now it's factored. Think about all the steps. First step, get the equation equal to 0. Second step, get it factored. Third step, separate the factors. And then the fourth step is to solve it. So Q equals 1/4. And Q is equal to -3/2. The main thing is, I want you to do it the right way. You either have time to do it right, or you have time to do it over. Questions on example 4? All right, last and final example. Example 5, 5x in the third minus 30x squared plus 40x equals 0. We finally got one that equals 0, so we don't have to worry about moving anything. It's already equal to 0, so that's good. Start with greatest common factor. We have a 5, a 30, and a 40, so everything divides by 5. Everything divides by 5. X to the third, x squared, and x, so you can take an x out of everything. So if you take out 5x, that gives you x squared minus 6x plus 8, still equal to 0. We did our first round of factor. First round of factor. Now we go inside parentheses. That's MAF. Possibly. Returns. Returns means you might have MAF working. So A equals 1, B equals -6, C equals 8. Turn it around and make it an MAF problem. 1 times 8 is 8. The add value is -6. So we need two numbers that multiply to 8 and add up to -6. That multiply to 8 and add up to -6. So we think about all the possible ways that we can get to 8. And then you figure out which one will add together to give me -6. Add those, you get 9. Add those, you get 6. Add those, you get -9. Add those, you get -6. There's our winning combination. Your leading coefficient was 1, so you divide by 1. That means your two parentheses are x minus 4 and x minus 2. 5x just comes down. Notice that I put the 4 first and the 2 second. It doesn't matter what order the two numbers go in. Questions before we continue? Got everything? Remember, think about your steps. First step, equation's got to be equal to 0. It's already equal to 0. Second step is to factor it. So in this case, we have to factor it twice. We have to factor it twice. Greatest common factor, and then MAF. We have to factor it twice. That's fine. We'll live. Now we separate all the factors. There's 3 parts. So each part gets set equal to 0. Each part gets set equal to 0. And then we solve each part. So each of these bite-sized mini equations, very easy for us to navigate our way through. Easy to navigate your way through. That's it. Problem's over. Any questions? Example number 5. Last example, solve equations by factoring. So you have to know how to factor if you're going to solve an equation by factoring. One of the questions that's on, a couple of the questions on your final, on your Unit 5 test, you have to solve it by factoring. That means if you use any other method, the problem is wrong. If you use quadratic formula and it said factor it, the problem is wrong. You have to know how to do it the several different ways. So any final questions before we do some housekeeping things before we close up shop? Pause.